Here's the complete guide to construction, quality and completions management. We're going to talk about everything from inspections and test plans, punch list and closeout. And we're going to give you strategies that are simple, effective, and you can apply to any type of construction project. Let's be honest, quality isn't the most exciting part of a project. I've heard people say they love estimating, scheduling, but I'm yet to hear someone who says they're obsessed with quality. Quality is all about discipline. It's about dotting your I's and crossing your T's. In an industry where profit margins are typically around 7 to 10%, considering that the average project spends around 5 to 10% of the project budget on defects and rework, it is an essential part of construction project management. Quality management isn't optional, it's the difference between making money and losing money on a project. So in this video, we're going to be covering why quality and completions matters, why it's essential to any type of project, what is quality and completions, construction quality management system, inspections and test plans, non-conformances, punch lists and defects, and effective completions management, before finishing off with talking about some of the biggest mistakes people make in running a quality management system. So before we dive into talking about how to manage quality, let's answer an important question. Why should we care? Why does quality matter? And more specifically, how does it help construction companies make money? Well, the first point I want to make is quality is your ticket to play. It's not optional, it's mandated by law and it's specified in contracts. As an example, in most countries, you can't get a certificate of occupancy for a building unless certain checks and inspections have been completed. That's quality. If you don't show compliance to the building code, you can't hand over your project, you can't get paid. And this applies in all industries, not just residential or commercial construction. Try connecting a solar farm to the grid and see how much paperwork you have to fill out. On top of that, it's almost always specified in construction contracts. In most construction contracts, there are certain quality assurance requirements that the contractor has to meet. If the contractor is not meeting them, they're in default of the contract. Your client can effectively stop paying you or show that you breached the contract and terminate the contract. Take, for example, the Australian Industry Standard Form of Contract, AS 4100. It mandates that contractors need to maintain and update a quality assurance system. Clients have the right to audit the system and also perform their own independent checks of the work being completed. And if they can prove the contractor is not complying, they can backcharge them, and it can even become a form of contract default. If you can't prove that what you're building complies with the project requirements, clients can and will stop paying you. On top of that, more and more clients are expecting contractors to hold certain licenses and accreditations like ISO 9001, the quality assurance system. To get certified and maintain the certification, your systems must be documented, audited regularly, and followed. So quality is your ticket to play. As a contractor working for construction companies, you need to be able to manage quality as a baseline for your job to continue delivering projects. The real question then becomes, should you just do the bare minimum, or is there benefit in going above and beyond? So next, I want to give you some reasons why you should maintain not only the bare bones quality assurance system you need to meet the contract requirements to continue getting and delivering projects, but why you should go above and beyond and treat quality as importantly as any other discipline in the project. So reason number one is your clients will notice. A clear, professional quality management system will build your reputation fast. Studies have found that one of the core things clients look at and judge the reputation of a contractor is how professional their quality management system is and how effectively they help them to close out the project and hand it over. Basically, if you make life easy for your clients, they'll want you to come back and do more projects for them. It's an easy and simple way to differentiate yourself as a contractor in a highly commoditized industry. Reason number two is commercial protection. So quality assurance records are more than just paperwork. Their evidence. I've seen this time and time again on a project. Recently, we were installing specialist electrical equipment. We had strong quality assurance records, and when certain bits of equipment started to fail, we could very easily prove that we had installed them correctly. It wasn't an installation issue, it was a supply issue, and we could claim the warranty. Detailed quality assurance records become proof of who did what, when, and where, and these will save you money in the long run. The third big reason quality can save you money is that it prevents delays between trades. Through your quality assurance system, you can check the work has been completed correctly and fully, and it'll prevent delays between subsequent trades. For example, if you've got a civil team installing pits and then an electrical team coming in after, if the pits aren't labeled, the electrical team don't know where they go, they're going to get much worse productivities. But if you've got to check within the civil installation that all the pits are labeled correctly, they've all been checked, they're all roped and mandreled, you're not going to get delays when the electricians come to site. QA checkpoints allow you to have fixed handovers between trades that prevent you bringing electricians, other trades to site and causing delays. Reason number 4, and the big one, is just avoiding defects and rework. As I've mentioned before, defects and rework typically cost between 5 to 10% of a project's value. I can't count the number of times I've seen simple things like pre-pour inspections save tens of thousands of dollars. Just think of QA as mistake prevention. Reason number 5 is closing out the project faster. Projects always fail during completions and closeout. No matter how effectively construction was managed, the schedule was adhered to, it's so common to see teams spend just as long finishing the last 5% of the project as they did doing 95% of the work. Why does this happen? Well, I call it kicking the can down the road. You get all these little jobs piling up, all these tiny little tasks that were too hard to do during the main construction. Maybe you needed special materials, maybe you needed labels to get reprinted. Everyone gets demoed, and then suddenly you end up with this 5% of the work that's the most challenging, tedious little tasks. They all pile up and they end up taking months and months more than anyone could have ever expected. A proactive quality assurance system where you're proactively identifying and closing out defects as you do the work will save you so much time during the last 5% of the work. So in summary, while most contractors treat quality assurance as a box-ticking exercise, it can and will save you money if you implement an effective quality assurance system. Smart contractors use quality to prevent mistakes, protect their business, impress their clients, and finish projects faster. So next up, I want to talk about some core principles of construction, quality, and completions management. I want to define the core terms you need to understand. These concepts are just going to help you understand the broad picture of quality management, completions, and how it relates to the objectives of the project. So the first one I want to talk about are requirements. So what is a requirement? It's just what we're getting paid to deliver, what our clients, what our stakeholders actually want us to build. So there's 2 core types of requirements, and understanding these is going to help you understand the overall terminology around a quality management and quality assurance system. So the first one are product requirements. These are the physical deliverables that the client wants us to build. They want a 3-lane bridge with guardrails, lighting, landscaping, so on and so forth. This is the finished construction project of deliverables. The second type of requirements we have on project are process requirements. So these are non-product deliverables, things we have to do, but they're not part of the finished construction project. For example, certain requirements about how the work has to be done. For example, we might only be allowed to work during certain hours. There might be quality assurance requirements we have to meet. We might have to provide evidence of how things have been built. We might have to give them concrete testing. We might have to give them certain electrical testings and sign-offs. There might be completions requirements, so things we have to hand over at the end of the job to help the client with handing over to their maintenance team. So we might have to do a training session. We might have to hand over spare parts. So we've got the product requirements, what we're physically building, and then we've got the process requirements. So things outside of the finished product, but we still have to do them as part of our contract. Okay, so where do requirements come from? Well, basically requirements come from contracts. We sign a contract to deliver a project. Attached to this will be supporting documentation that defines what we have to deliver. So we can have drawings and design documents attached to that. We can have project specifications, contract clauses, code and statutory obligations, standards, international standards, or we might have third-party or client standards. So why do requirements matter in the context of quality? Well, requirements define the baseline against which we measure quality. Effectively, we're being paid to build something. What we're being paid to build is defined by the requirements. Therefore, the requirements define the baseline against which we measure quality. The purpose of quality is to measure we've delivered the project in accordance with the requirements. Okay, this then helps us to actually define what quality is. So what is quality management? It's the system to verify and validate that the constructed product meets the original requirements. For example, the design drawings show us that we have to build a 3 meter by 2 meter tall concrete footing using 32 MPa concrete. The quality system is then going to verify that we're using 32 MPa concrete, that we're including test results to show that it's measured strength, that there's been a survey check to check it's in the correct position, that there's been a pre-pour inspection. Then the quality assurance documentations is the documented proof that what we've built matches the requirements. Now, I'm going to introduce you to another incredibly important concept when talking about quality in completions, and this is systems engineering. So systems engineering is a model that illustrates how requirements are defined and validated throughout the life cycle of a project. So this comes from software engineering, commissioning, a broad different range of types of projects, but the principle is very similar. You start with a project definition phase where you go from requirements, you progressively elaborate these through establishing the requirements, defining them better, producing a concept design, checking this concept design meets the objectives of the project, doing the detailed design, getting to an IFC stage, then constructing this design, and then we go through a series of testing and integration to always verify and validate that these requirements have been met. So you start on the left side, starts with general project goals, they progressively turn into design specifications, and on the right side of the V, you can see that as we move from something being built, we're testing and commissioning to check these requirements have been met. The systems engineering model is the easiest way to think about how design, quality, and completions all relate. I'm going to talk about this a little bit more, but it's basically this understanding that a requirement gets turned into a design, gets constructed, then goes through a series of testing, basically that we prove that the original requirement has been built in accordance with the original requirements. Now, this relates to the next important point, which is the relationship between quality and design. Design is the process where we define the technical solution that meets the requirements. Quality management is then ensuring that what we have constructed conforms to the design. Now, this is a very construction-specific definition of quality and design. For example, in software, other types of projects, they speak about quality more holistically. But in other words, when we're talking about construction project, the design is telling us what we need to build, then quality is really ensuring that what we have built complies with the design. That's why design development is a critical part of overall project quality management and is essential to a proper functioning quality assurance system. Okay, so building on this definition, we come to construction quality assurance. So our definition of quality assurance and a quality assurance system on construction project. In construction quality assurance, we focus on compliance with the design documentation, the drawings and specifications. While holistic project quality management focuses on this entire systems engineering V, which includes defining the original requirements, turning these into an IFC set of drawings. When we talk about construction quality management, we're talking just about this. We're talking about compliance with the design documentation. So while quality theoretically covers the overall process, when we're talking about construction quality management and a construction quality management system, we're talking about inspections, material testing, conformance checklists, and basically everything that we do to verify that what we've built matches the drawings. The essential point here is we're not checking the drawings are correct. Okay, the next concept, and this is a term you've probably heard about, and it's opening a bit of a can of worms speaking about it, but commissioning. Commissioning is something that applies more to mechanical, electrical process systems, but basically commissioning is this part of the V. It's how we prove that what we've built meets the original requirements as opposed to just testing something meets the design. So for example, we install an electrical cable. As part of our construction quality assurance checks, we'll check that the cable's correct, that it's labeled, that it hasn't been damaged during installation. But we're not checking, is the cable the right size? Is it measuring the correct voltage? Commissioning system will actually check that stuff. So you're checking that the load on the cable is correct, because you're also validating that the cable has been designed correctly. Commissioning moves through a series of stages where you test higher level and higher level requirements to effectively you're checking the overall system functions correctly. Okay, what is completions? Well, completions is us wrapping up the project. If you remember, we had two different types of requirements. We had our product requirements, which were the physical things we're building. That's what the construction quality assurance system checks. Checks that we're building things correctly. Completions is about ensuring all our process requirements have been met. Have we completed all our quality assurance? Have we packaged it all together? Have we done our owner training? Have we got our spare parts? Completions is really about how we document, wrap up the project, and then submit it back to our client. It's the entire process of doing our final quality assurance closeout, getting our as-built drawings, our operations manual, training handovers, all our statutory sign-offs, and filling out all our client documentation. If we talk about the differences between quality and completions, quality ensures that the work is correct and compliant. Completions ensures that everything is delivered and documented so the project can be closed off. In this video, I want to give you the ultimate guide to construction quality management. If you're getting confused by all the different terms like inspection and test plan, inspection and test check sheet, punch list, defect list, category A defect, all these different terminologies, don't worry. In this video, I'm going to spell out exactly what a construction quality management system does from start to end to achieve the project objectives. By the end of this video, you're going to understand the role of all these different components of a quality management system, and importantly, how to set up and manage a construction quality management system on your project. Implementing formal quality management systems has been proven by studies time and time again to lead to more successful project outcomes. So if you're wondering if there's something you can do to improve your job performance, accelerate your career, the mastering construction quality management is without a doubt should be the top of that list. Everybody talks about quality management. It's so important. It does this, it does that, it does whatever. However, people, in my experience in the industry, tend to miss the point. That's why I wanted to make this video, and I wanted to step through what are the components of a quality management system, how do you use them, how do they relate to project success, and how do you set up and manage one. So that's what I really want to break down as simple as possible. So in this video, I'll go through what is a quality assurance and quality management system, the difference between project quality assurance and construction quality assurance, the link between design and quality, what commissioning is and how it falls into the overall system, the components of a quality management system, and then finally, the biggest mistake I see people making time and time again when they're managing construction quality. To understand what a construction quality assurance system is, you really have to think about the life cycle of a construction project. It starts with a set of drawings and specifications. We build the project according to these drawings and specifications, and then we create a finished product. The role of the quality assurance system on the construction project is to ensure that the finished product, what we built, complies with the drawings and specifications. So the construction quality assurance system is what relates the finished product to the original drawings and specifications. It's the processes we follow to ensure that what we built matches what we intended to. There's a very important distinction between project quality management and construction quality management. So project quality management is about ensuring the project meets the original requirements. So it's about the original requirements and ensuring what we've built matches it. Construction quality assurance is about checking what we built matches the drawings and specifications. So these might sound exactly the same to you. However, there is an important difference. The difference is the construction quality assurance system assumes that the drawings and specifications capture the project requirements. So then it's about ensuring that what we build complies with the drawings and specifications. Construction quality assurance is a subset of project quality assurance, because project quality assurance also has to check that the drawings and specifications cover all of the project requirements. That checking that the drawings and specifications capture the project requirements isn't a part of construction quality assurance. Construction quality assurance is simply checking and verifying that the drawing and specifications match the finished product. Now, this process of transferring the stakeholder requirements into a set of drawings and specifications is design development. So design transfers all of the different stakeholder project requirements and turns them into a set of issue for construction drawings that the construction team then take and then build according to these plans. For example, a stakeholder requirement might be, we want a 10-story building, or we want the building to have an external facade that looks like this, or the building code requires us to have 2 fire extinguishers on every floor. So these are the stakeholder requirements that get integrated into the drawings and specifications. The assumption behind construction quality assurance system is that the design captures the stakeholder requirements, and somebody's checked the design to ensure that what's captured on the drawings meets the original project requirements, and therefore the role of the construction quality assurance is simply to check that what we're building matches the drawings and specifications. And I understand if anyone's worked on projects that involve both design and construction, this is never true. The design always has mistakes. It always has issues and errors. However, that's not the purpose of the construction quality assurance system. The purpose of the construction quality assurance system is simply to check that what we're building matches the drawings and specifications. Checking that the design correctly captures all the stakeholder requirements falls under design quality management. So the design quality process is there to ensure the design fills stakeholder requirements. We can break this down into 3 sub-processes. First one is quality assurance during the design phase. So while we're preparing the drawings and specifications, we're checking, are they correct? Do they meet all of the requirements? Once our stakeholders are satisfied with them, we've checked them, they get an issue for construction drawing set, which means as the constructor, we can then begin constructing off the drawings. This moves into the construction phase, which is all about identification of errors and issues during the construction phase through the RFI process, where if we want to change the drawings or we identify any issues with the drawings, things that don't work during construction, we go through a formal change control process. Now, I call this an RFI, a request for information. Other people call them TQ, technical queries. They all mean the same thing. They're checking with the designers during the construction phase if we want to make changes. The final part of the design quality assurance process is the commissioning process. Now, if you've heard the term commissioning, you might tend to think of it as something different. However, when you look fundamentally at what commissioning is, it's checking that what we've built functions as per the original requirement. So it's going a step beyond checking that it functions as per the design. It's about checking that what we've built functions as per the intended requirement. So commissioning is also an important part of the design quality management process. So now I'm going to go into a little bit more detail breaking down these 3 sub-processes of design quality management. And I know they don't directly form part of the construction quality management process. However, understanding how we check that the design meets stakeholder requirements is an important part that will feed into the construction quality management process. The first one is quality assurance during the design development process, which is the process we follow to ensure the drawings and specifications are correct. When we say correct, we really mean 3 different things. First one is that they capture and fulfill the stakeholder requirements. So they produce the technical solution that fulfills the intended stakeholder requirements. Second one is they're free from errors, that they're actually correct. And the final part of this is that they're constructible. So within the realms of what's possible in terms of the construction, that we can actually build what the drawings say to do. The design quality assurance process has to check these 3 things. Then it's check stakeholder requirements, they're free from errors, and that we can actually build it. The tools that are used to ensure this is done correctly would be regular and independent checks of the design and validation of the original project requirements against the design. Once we move into the construction phase, the drawings get an issue for construction stamp, which means they're ready to be built. We then go have a design management process during the construction phase. So this is the process to ensure we manage changes to the design during construction, and this will ensure the design remains correct. So any times the drawings are changed, it needs to get approved by the design team. Once the design team check that the change is okay, that it's technically feasible, that it still complies with the project requirements, the change gets approved and reissued to the construction team, and then they're able to build this. So the tools we use to do this would be RFIs. So this is a request before the fact change of the design. NCRs, where we have some sort of error or issue during construction and when we're not able to build what the drawing specified. And then the final type would be a direction from the design team to change the design that's not prompted through construction. So for whatever reason, the client has required additional scope, they've required something additional added to the design, the designers will integrate this into the drawings and issue a design change notice. And so the final part of our design quality management system, and it's not strictly a part of design management, however, it's useful to think of it as part of the same process, is where we take what's finally been built and rather than checking this just complies with the drawings, we actually check it complies with the requirements. So this is the role of the commissioning process, where we're checking that what's been built functions as intended, not just as what's been built. So to understand commissioning, we need to understand systems engineering. So systems engineering is where we're designing, integrating, and managing complex systems throughout their life cycle, and ultimately relating a system as it's built back to how it functions. So we can relate a project's initial objectives and requirements to the design, the development of the detailed design, the construction, and then the testing. So we start with an investment decision or a decision to proceed with a project based on the requirements it fulfills. We then develop a concept design that fulfills these requirements. We then move into a detailed design where we add detail, work out the finer details, work out exactly what we need to build. We then go build this, and then commissioning is the other side of this V. We go from low levels of detail, we test something at the unit level, and then we continually go through a process of testing bigger and bigger portions of the system till we're ultimately checking the entire system functions as originally intended. So construction quality assurance checks that what's been built matches the drawings. Commissioning is where we're checking that what has been built functions in accordance with the project requirements. So this starts at a unit or device level, we move up to a subsystem, and then we're checking and verifying the overall system. So if we think about this in terms of the solar farm, so the original project requirements, the investment decision to build the solar farm was based on building a 50 megawatt solar farm. The design says we need to install 45,000 panels. Construction quality assurance then checks that all of these 45,000 panels have been installed correctly. Commissioning, through the commissioning process, will then check that the solar farm correctly exports 50 megawatts. So if you understand, construction quality assurance is about checking all the 45,000 panels were installed correctly. Commissioning will then energize the system and slowly check that each set of panels is exporting the anticipated amount of power at a certain irradiance. And then as we're bringing on more and more power, are we reaching the 50 megawatt export threshold? Okay, so I've spent a ton of time talking about design quality management and commissioning. Purpose of that was to clarify in your mind how we go from the initial project requirements throughout the design to construction, to commissioning, to checking, ultimately that we've built something that matched the original requirements. Now, also said the design quality management and commissioning aren't form of the construction quality assurance process. The goal of the construction quality assurance process is to check and verify that what we've built matches the drawings and specifications. So now I'm going to talk about what does a construction quality assurance system consist of? What are all the different components of them and how do they work together to achieve this goal of ensuring that what we've built matches the drawings and specifications? Okay. So let's map out all the different components of a construction quality assurance system across the life cycle of a project. So we've got the inputs to the process, then we've broken the project life cycle up into 3 distinct phases. We've got the planning phase, the executing phase, and the completions phase. So the inputs to the construction quality assurance system will be the project requirements and the design drawings. So that's what we're ultimately checking, that what we're building is correct. We're checking this against any project or design specifications and design drawings. These get input into our document management system. Now, people don't often understand the importance of an effective documentation management system, but it is the backbone of the quality assurance system. The quality assurance system will not work correctly unless we have some way of tracking all of the different drawings, specifications, and making sure they're correct and are the correct revision. So that's the documentation management system, critically important to any construction quality assurance system. Then what we do is we take all the drawing and specifications that define the scope of the construction work and we turn these into a work breakdown structure. So we take the overall project scope, we decompose it into component pieces. We create a breakdown of all the different construction activities. The next thing we need to do is for each of these different construction activities, we need to prepare an inspection and test plan. So against the specific construction activity, what checks are we going to be doing? We also need to write for each of the inspection and test plans a series of short inspection and test check sheets. So these are the physical check sheets that people are going to go out onto site and complete to check the work's to be done correctly. Supporting this will be a series of other documents like calibration records for our test equipment, documenting all the licenses and accreditation of the workers, and supplier quality assurance systems for any major materials we're procuring. So they'll support this process, and we set up as well during the planning phase. Once we've prepared all our quality management documentation, we move into the execution phase. This is where we're delivering the project works. This is really simple what we have to do in the execution phase. We just have to follow the inspection and test plans. We just have to follow the plan we set out for each of the construction activities and go through the steps in the ITP. There will be changes during construction, so that's why we have the RFI process where we deal with changes to the design drawings, and they'll also feed in to the ITP process. Once we complete all the inspection and testing for a specific construction activity, any deviations from the standard, so any failed inspections, any failed checks, we need to document in our punch list. So a punch list is all it is a record of all the defects on the project. If we're going out and doing a visual inspection of a solar panel tracker and we notice it's missing cable ties, we note that down, that gets added to our punch list. To close out the project, we simply go through, send people out to fix every defect and document that all the deviations for quality standards have been correctly documented. We go through and do a handover walkthrough with our client. We show them what we've built. We show them the records. We show them all the test records, and we get them to sign over acceptance of the work to agree that we've built what we've said we would in accordance with the drawings. Additionally, any changes during construction have to be documented on the drawings and specifications and captured in our as-built drawing set. That is the construction quality management system, where we go from the initial project requirements and we turn these into a series of checklists against each of these activities. We verify that they've been built correctly. We document any defects in our punch list. We close out the punch list. We get acceptance from our client, and that's all we have to do. Okay, I know I ranted a little bit going through that structure, but to make things a bit clearer, I'm going to go through each of these individual components step by step and what it contains. So the first one is project requirements. So they're the primary input to this process. It consists of the drawings and specifications, project specifications, and any relevant standards that we also have to comply with. These are all the documentation that define what we need to build. Okay, the backbone to the system, the documentation management system. All of these different drawings, specifications, project requirements need to be captured in some sort of documentation management system, which is a system simply to control and manage all the different project documents and to check that they're correct and the correct revision. So we could use something like TeamBinder, Aconex. There's a lot of different softwares out there, but they all operate with the same intended purposes. They capture all the different project documents, and then as documents change, we get issued a new revision of the drawings, there's an RFI, whatever. This all gets captured and updated in our documentation management system, so we have a single source of truth we can go to and extract the correct drawing. So we've uploaded all our drawings and specifications into our document management system. The first thing we need to do when setting up our quality assurance system is develop a work breakdown structure. It blows my mind how many people miss this step. But what we need to do is to take the scope of what we're building, what we're delivering, we need to break it down into component pieces. So we need to break it solar farm down into earthworks, mechanical installation, electrical, procurement, however you choose to do it. The idea is you break the project down into individual activities, and then the individual activities we've broken down the scope into, we then perform inspections and testing against each of these individual activities. So what we want to do is ensure the entire project scope is covered and no testing activities are missed. Once we've broken down the project scope into component pieces, each of the items of scope we identify, we need to prepare an inspection and test plan. So an inspection and test plan identifies every step in the construction activity, and against each of these steps, we document what checks we're going to do to ensure that activity is completed correctly. We want to pick up what could go wrong and what we're doing to ensure that we either prevent something going wrong, or if it goes wrong, identify it and correct it. So the structure of an ITP would consist of a pre-work section where we talk about procuring the materials, checking the drawings are correct, making sure everyone doing the work is appropriately qualified. A construction part where we go through all the different steps of the construction process, and against each of these we might do an inspection and test check sheet. And then a closeout, where at the end of the work we do any final testing, close out any defects and NCRs, and complete any red line markups to the drawings to document changes. Once we've completed an ITP, we've written how we're going to perform the checks for each construction activity. We need to submit this to our client to get their approval. As part of our ITP, we'll reference a sub-document referred to as an inspection and test check sheet. Now, again, people call these a whole lot of different things, but basically what it is, it's a really simple, short checklist we complete during construction in the field to check something's been built correctly. So an ITP you wouldn't complete in the field inspecting the works. That's what a check sheet is for. So check sheets, one page, very simple, should cover things like a pre-pour inspection. So before you're pouring concrete, you do a pre-pour inspection checklist, or if you're testing an electrical cable after it's installed, you might have an electrical cable test sheet. So it just documents every step in the construction process, and at a predefined point, we'll complete an ITC and check that everything is done correctly. So our ITP will reference multiple ITCs. Once we've prepared all our ITPs and ITCs, they've been submitted to our client's reviewed them, accepted them, approved them. We then go out, complete the construction works, and complete our inspection and test plans. As we're doing our testing, as we're doing our checks, we'll identify failures to comply with the project requirements. We'll identify issues. So we might be missing cables from an electrical cable, or we might be about to do a concrete pour and notice that the formwork hasn't been braced and supported correctly. If that's the case, all these failures to comply with the project requirements get documented in a punch list. So a punch list is a record of all defects and any minor outstanding works that are categorized appropriately and given a responsibility to close out. We need to work our way through the punch list, close all the defects to prove that we've correctly completed the construction works. Through this construction process, there will almost certainly be changes to the design. So that's where the RFI, or request for information process, enters into the construction quality management system. So through construction, there's going to be changes to design. We manage these through the RFI process, which is basically a formal change management process that when we're changing the design, we get this approved by our clients, we get it checked, and we get direction and approval from the client and the design team before proceeding with any changes. Importantly, if an RFI changes a drawing, it needs to go into the documentation management system. It needs to get uploaded to the documentation system so that everyone is working off the same set of drawings. There's nothing worse than getting sent an RFI response not updating the drawings in the documentation management system and someone going out and doing the work incorrectly because the design change hasn't been passed on to them. So it's critically important that when there's any changes to design, these are getting up-revved in our documentation management system. All these changes to the design need to be captured on a set of drawings referred to as the red line markup. So the construction team, as they build the project, document any changes in red pen on a set of drawings called the red line markups. And at the end of the job, these get resubmitted to the design team, who then create an as-built drawing set capturing all of these changes. After we've completed all our construction works, finished all our ITPs, closed off all of our defects, we can then complete a handover walk with the client. So this is a joint inspection we complete with our client, where we inspect the work, we show you what we've done, we show them our completed ITPs and ITPs, we give them confidence that what we've built matches the drawing and specifications. The purpose of this walkthrough is it gives them an opportunity to add to the punch list. So the client might identify something that they're unhappy with, that they want changed. This is their opportunity to add to the punch list, and if it is a reasonable request, so if it is a failure to comply with the project requirements, we'll need to go and fix it. In a lot of circumstances, what I've found in my own experience doing these sorts of walkthroughs is the client basically picks up a whole lot of things they're unhappy with about the original design. So that's why I find when you're doing these joint inspections, it's incredibly valuable to have a member of the design team, that somebody like the design manager who you can complete these inspections with, and they can comment on why the design was done a certain way. Because often on these walkthroughs, yes, they pick up some construction defects, but a lot of the time what they're identifying is problems with the design, and it's endlessly frustrating that then you then have to go and check all these things with the design team, and you become a line of communication between the client and the design team. So that's why I think it's incredibly valuable to have a member of the design team there. In terms of the construction, if they do add things to the punch list, then the same with any failed inspection and testing, we simply have to close out these punch list activities, provide evidence to the client, so we can then show them that what we've built complies with the requirements. Okay, so what did we just discuss then? We went through all the individual components of this system and how they function to ensure that the initial project requirements and design drawings get checked, verified, and that what we've built, what we've finished off creating, matches these original requirements. So what is the biggest mistake I see people making when they're setting up, managing, and using a quality management system on construction projects? Biggest mistake I see people making is they fail to integrate quality management with contract management. The purpose of the quality management system is to check and verify what we've built meets the original requirements. The original requirements come from the contract. That's how the client bases whether they pay us, whether they don't pay us, whether we get into disputes, is ultimately comes down to us providing evidence that what we've built matches the original project requirements. So quality has significant contractual implications, both in terms of the payment process, so whether we get paid, when we get paid, and it should be integrated into the payment milestones and integrated into the contract. And this is going to benefit the overall project because it gives the client the opportunity to ensure works have been satisfactorily completed, and gives the contractor an opportunity to justify getting paid and showing that they've done the work correctly. So in conclusion, integrate quality management with contract management, follow these steps, follow this process to set up and manage a quality assurance process, and I can guarantee your projects will become more successful. Inspection and test plans are an essential construction management tool. However, the reality is most people write and use them incorrectly. That's why in this video, I'm going to explain to you everything you need to know about construction, inspection, and test plans. So in this video, I'm going to go through what is an inspection and test plan, how they're used, what they contain, the structure of one, how to write one to use them effectively to make sure you're using them to minimize defects and avoid errors. And finally, we'll go through an example ITP. So an inspection and test plan, or ITP for short, is a document that outlines the procedures, tests, and inspections required to ensure that a construction activity meet the specific quality standards and requirements. So if we think about pouring the concrete foundations for a building, there's a series of activities involved in this process. We need to order the concrete. We need to set up a concrete pump. We need to place the concrete. We need to finish the concrete. And then we need to check that it's all been installed correctly. The inspection and test plan documents all the steps in this process and checks against each of these steps what could possibly go wrong and how do we check it's done correctly. So it'll check, is the concrete mix correct? Is the placement method correct? Is the formwork being stripped after a certain amount of time? All these things are documented in the inspection and test plan. The ITP contains every single step in this process and ensures they're each done correctly and provides evidence and records that the works have been completed correctly. So inspection and test plans are required for all significant construction works, things like piling, conduit installation, concrete pours, and any permanent construction works. But what about temporary things? What about things like traffic management or establishing site facilities? Well, typically you wouldn't do an ITP for these sorts of activities because they're non-permanent and they're not getting handed over to the client. Sure, you might have a checklist you follow to ensure things are done correctly, but it wouldn't follow the same strict and stringent ITP process. All ITPs need to be prepared before the construction works begin, and importantly, they need to be approved by your client or relevant stakeholders before the works begin. So that's a critical point to note. We write an ITP, we document how we're going to check everything's been done correctly, and we need to get our client to review these to ensure that they're happy with them. Okay, so now we understand what an inspection and test plan is. Let's look at an actual ITP. So ITPs follow very specific structures. You'll have a heading with the project details, so some background, the project name, the scope of the inspection and test plan, what work packages it refers to, what drawings it refers to, any applicable standards, who wrote it, the date it was prepared, that sort of information. Then you'll have, say, some definitions, so the symbols, who is doing the inspections, the different inspection activities. And don't worry, I'll attach a copy of this to the course notes so you can refer to it yourself. Then ITPs follow a specific structure where you have the test activity, which will be the series of steps to complete the construction work. So you might have pre-works where it's checking the drawings are correct, making sure permits are in place, checking that the works have been surveyed, the procurement of materials, so buying all the equipment we need. So for example, for this activity, we need to buy conduits, what applicable standards refer to the conduits, and how we're going to check if we've purchased the correct conduits, construction activities. And against each of these activities, we've got the specifications that apply to it. So what specifications relate to checking this work's done correctly? What test method are we going to use? How often are we going to do the testing? What are the acceptance criteria? And who is responsible for this? So that's how ITPs are structured. They go through all the steps in the process, the different construction activities, then the specifications that apply to that activity, the test method that's going to be used, the timing and frequency of the testing, the acceptance criteria, and who's responsible for performing those checks. So now we understand what an ITP document is, what they look like. The next thing we need to understand is how to write an inspection and test plan. As a construction project engineer or manager, you're certainly going to have to produce some of these. So it's important to understand how to actually write one. The steps in writing an inspection and test plan will be number one, to review the drawings and specifications of the scope you're writing the ITP for. Develop the construction methodology, so understand the steps in the process of building one, list out all of these steps, identify which detail and information does the drawing show for each of these steps, and understand what can go wrong. If you understand what can go wrong, you understand what needs to be checked to ensure it's done correctly. Fill out all of the relevant supporting information, so the relevant drawing and specifications, the frequency, these sorts of things, and then submit it to the client for approval and get them to provide some feedback and comments. So ultimately, when you're preparing an inspection and test plan, what you really want to be documenting at the checks we do around the things that can go wrong. That's the ultimate goal of why we're preparing the document. We want to create a big list of everything that could possibly go wrong for that specific construction activity, and then check that we're not going to make those mistakes. So for example, with concrete works, we could incorrectly get the survey set out. So the surveyor might be working off the wrong set of drawings, or the drawings might have a wrong height on them. Could use the wrong concrete material. We might procure a type of concrete that's not applicable to that scope. We could use the wrong placement method. There might be some standard way we can't allow concrete to drop more than 2 meters. It might not be compacted or vibrated properly and get air pockets. We could use the wrong type of formwork, or the formwork might not be correctly braced so the concrete collapses. We could have the reinforcement move during the pour, so we no longer get the correct cover on the reinforcement. We might miss installing cast-in items. Maybe there's a surface penetration because we haven't checked those were installed before we poured the concrete. We missed doing them, or we missed installing cast-in items like bolts. When you think about it, for any construction activity, there's a lot of things that can be done incorrectly. So our job when we're writing the ITP is to come up with a list of all the things we need to check to ensure that we're not going to be making these mistakes. Each of these mistakes we could possibly make are going to relate to a step in the construction process. So the basis of our ITP is all the steps in the process we follow to deliver the works. Now, regardless of the specific construction activity, there's some broad steps that any construction works are going to follow. So these I like to think of as pre-works, the stuff we do before we start the construction activity, the actual construction activity, and then the closeout activity. So the pre-works will be things like design, so checking the drawings and specifications correctly. If we're procuring materials from a supplier, they might have given us shop drawings. We might need our designers to approve these shop drawings. So they're all the design activities. We'll need to buy materials. So basically we want to check we've bought the correct materials and they match the specifications. And we've also had any handover from previous trades. So for example, if we're installing underground electrical cables and the civil contractor has put in the conduits, has the civil contractor checked that all the conduits are free from debris and they've been roped correctly? So they're all the handover activities. Then we move into the construction. So this is really step-by-step the construction activities involved in that task and checking against each of those what could go wrong, and then the closeout activities. So any final testing we do, for example, for concrete, we might get concrete testing done, documentation of any as-built drawings or changes to design, and then handover to subsequent trades or final acceptance by the client. So those are the steps we want to document for every single activity. Next to each of the steps in the construction work, we document the relevant specifications. So for each of these steps, there'll be a specification that governs whether it's done correctly. So these specifications might be from project specifications, notes on drawings, or relevant standards. For example, if we're installing concrete reinforcement, there'll be a specification that says the cover we're allowed on the reinforcement, and then that's what we need to check. So we're allowed 50 mil of cover in the specifications. We check that we've got 50 mil of cover. We're allowed 100 mil. We check we've got 100 mil. So once we've documented the steps in the construction work, the relevant governing specification, the next thing we need to document is test method. So what is the test or check we're doing to ensure the works are done correctly? So this could be specific to a discipline. So it might be concrete testing or compaction testing for earthworks. Or they could be generic, so visual inspections, recording photos, or getting material dockets. Next, we need to define the timing and the frequency of these checks. So how often will this testing be undertaken? So it could be time-based. We might do the checks every day or every week, or it could be activity-based. More common for construction works, there'll be activity-based checks. For example, every lot of earthworks, or if we're installing underground conduits, it could be every 20 meters of trenching, or we might do it per concrete pour. So for every concrete pour, we'll do a pre-pour inspection, we'll do an inspection while they're placing the concrete, and then we'll do a series of post-pour checks. So more likely your timing and frequency is going to be activity-based. And then we need to define our acceptance criteria. So what is the standard the testing has to meet? For example, for our concrete testing, we might need to achieve a strength of 32 MPa within 28 days. If we've installed an electrical cable and we're doing an insulation resistance test, we might need to achieve greater than 50 mega ohms when we do the test. So these could be test results, they could be subjective verification by an expert, they could be records like photos, or they could be certain design criteria. It really depends on the specific check we're doing or the specific test as to the acceptance criteria. The final thing for each of these different steps in the construction process, we need to define who is responsible for approving it. So these could be internal to our company, or these could be external experts we engage, or it could even be the client who has to check. So it might be a subcontractor who's doing it for us. It might be an engineer or a project engineer. It could be a supervisor. It could be the client or their owner's engineer, or it could be another relevant stakeholder. So it's important to define for that specific activity who is responsible for checking and approving the checks. Now, when we're defining who is responsible, we also define what level of oversight they give the step. So there's 3 different types of responsibility. It could be a hold point where works cannot proceed past this point until that person's approved it. So for example, on a concrete pour for a pre-pour inspection, it might be a hold point for the client's structural engineer. So the client might need to go out and inspect the reinforcement before they give approval to pour concrete. It could be a witness point where they just have to be told about it, but they don't necessarily need to inspect it. Or it could be a review point where they review it after the fact. So it really depends on defining what level of inspection the responsible party needs to undertake. Okay, to make this all a bit more realistic, let's go through and do an example of a conduit installation or ITP. So if you don't know what conduit installation is, it's installation of underground pipes that people use to install and pull electrical cables. So it involves trenching, laying the conduit, and then backfilling and compacting. So we're going to go through and do an example inspection and test plan of conduit installation. So you can see people practically what's involved in an ITP. Okay, let's start with what would be the inputs to this document. So we've got the design, the drawings and specifications that show where the trench is going and the details of the trench. So I've got a simplified example here that shows a cross-sectional view of the trench, which shows the conduits in orange. There's 3 100mm electrical conduits. They've got 600mm cover, and there's bedding sand around the conduits. And then we also need to install a marker tape, which shows where the conduits are. The methodology is they're going to excavate, they're going to lay the conduits, and then backfill. There's specifications around the materials we're allowed to use. We need to have an excavation permit in place before we do any works, and we need to do compaction testing and mandrel testing. So mandrel testing is when you pull a sort of like a plastic ball through the conduits to ensure that they're clear of debris and that there's space in them to pull cables through. So we need to do compaction testing and mandrel testing. Okay, let's start with our table from our ITP. So this is the structure we're going to have to populate. We're going to have our pre-work. So this will be checking the drawings are correct, ordering the materials, our construction works, which will involve those steps I went through, excavating, installing the conduits, backfilling, and then any closeout activities. So now we go through and populate this table with every step in the process and then all the other relevant information against each of these steps. So for the design check, we've got the issue for construction drawing set. We need to check that this is prior to performing works. And the acceptance criteria is before starting works, we have an issue for construction set of drawings and approved RFIs. Requirements around the procurement of materials. So we need to procure the conduits. The conduits we procure have to comply with AS3000, the design requirements and the project specifications. We're going to check this each delivery, and the acceptance criteria is we're going to collect every single delivery docket we get for conduits and attach these to our ITP. And the site engineer is responsible for this. Then we've got our construction activity. So the trench excavation will be, the activity is excavating the trench to the correct design depths, the relevant specifications, and we're going to, every 20 meters, we're going to check this is done prior to conduit installation. And we're going to get the surveyor to check the depth of the trench against finished surface level. So every 20 meters, the surveyor is going to check that the depth is correct against the finished surface level. So as you can see, relevant specifications, the testing we're doing, how frequently we're doing the testing, what the acceptance criteria is, and who's responsible for the checks. Okay, so once we've written our ITP and prepared it, who has to approve it? So internally, the project quality team or any managers we have would typically approve it. Then we need to send it externally to the client to approve. This is critically important because we want the client to review how we've written the ITP and make sure they're happy with the checks we're doing. Because at the end of the day, at the end of the job, we're going to submit all the ITPs for them with their acceptance, and that's how we're going to prove to them we've correctly delivered the project. So it's important that they are allowed to make any comments, that they're happy with the level of testing we're doing, that they believe it also complies with the standards, but it's going to make closing out the job at the end of the project a million times easier. And then once we move into construction, all we have to do is complete the ITPs as we're completing the construction works. Simple as that. The effort we put into managing process is in correctly writing the ITPs, documenting all the checks correctly, and then all we're doing as we move into construction is going through step by step, ticking off, doing all the checks, getting all our delivery dockets, organizing all our testing, getting photos and records. It's easy as that. And when we're done at the end of the job, we submit them to our client and we can prove we've correctly completed the works. We're going to minimize the number of defects we have. Any defects we do get, we'll easily be able to address, and we'll have records of where those defects are. In this video, I want to teach you how you can become a better construction project manager by more effectively managing non-conformances. Non-conformances can increase project costs by 10% and delay the schedule by around 7% based on a study by the Construction Industry Institute. So, in an industry with razor-thin profit margins, non-conformances are a good place to put your time and attention and focus on effectively managing them to ensure your projects are a success. Okay, so in this video, we're going to be covering what a non-conformance report is, the difference between a non-conformance and a defect, the components of an NCR, how to prepare an NCR, and then finally go through an example NCR. Okay, so an NCR is a formal document used to identify, track, and resolve instances where a project does not conform to specified standards, requirements, or plans. So we've already defined a defect as any failure to meet the project requirements. An NCR is just a significant defect. So if a defect is significant to the operation of the plant, to the functioning of what we're building, or even commercially significant. So if it's a large dollar value item, we would turn that into a non-conformance report. So a defect is any failure to meet the project requirements, and defects can be both minor and major. Minor defects might be something like missing labeling on electrical cabling, while a major defect could be an incorrect cable installed that needs to be cut out and replaced, and it has a significant cost and prevents operation of the plant, so it's significant also to the operation. NCRs are a formal process we go through to capture significant defects. Depends a bit on the company and project specifics of how they choose to manage them. However, NCRs have the characteristic that they're significant. So going into more detail on this, you should raise an NCR when a defect is commercially significant, so it could have implications with the contract we have with our clients, or the contract we have with our subcontractors. It's going to take some time to fix, or it's going to have a significant cost. Additionally, we should raise a defect when we want to proceed with some sort of investigation, root cause analysis to work out why this defect has come up. Or we should raise an NCR when we want to change the project standing. So if because of we can't for whatever reason close out a defect the normal ways by just rectifying it to meet the original standard, if we want to raise an RFI to the design, change the original standards, then we should also create an NCR. NCRs have several different components. So first off, we'll need to identify and define the NCR. So we talk about what the scope is and what happened. We'll then need to analyze the root cause. So work out what happened and what the underlying cause of the defect was. We'll need to work out how we're going to resolve the defect, and then we'll need to work out how we're going to prevent the same thing happening again. So first off, when we identify an NCR, so NCRs like defects will be identified during inspection and testing. So as we go through and complete our ITPs, if there's any failures to meet the project specifications, that'll create a defect. The significant defects become NCRs, or we could identify them through an audit. So we might go out and do systematic audits and checks of processes or products, and we could also identify NCRs like this. They can be identified by our client, by the contractor, or by subcontractors. So really anybody involved with or working on the project can identify NCRs. So the next component of the NCR is the analysis. We need to analyze what happened, why it happened, and what we can do to fix it. So we identify the cause of the NCR. We identify who's responsible. Now this is important commercially, correctly identifying the responsibility of rectifying the defect. Because remember, we said NCRs were significant defects, so there's significant cost and time associated with them. So appropriately identifying who is commercially responsible for fixing it is important. And we also want to identify, why did the NCR happen? Was it due to incorrect design drawings? Was it due to incorrect procurement of materials? Or was it due to incorrect workmanship? We then need to come up with a resolution for the NCR. So there's a couple of different things we could do, and depending on what we choose to do about the NCR will require different approvals from different parties. The first one, the easiest way to fix it would be to rework the defect to meet the original standard. We simply redo the activity to meet the original project specification. The second thing we could do is we could accept the defect as it is without repair, or we could repair it with concession. So we could repair it to meet a new, different standard. These are different because number one, reworking to meet the original standard, we would need no change to the project requirements, which means we need no approval from the design or no approval from the client, because all we're doing at our own cost, we're fixing the defect to meet the original project specifications. Options 2 or 3, where we accept the defect as it is, or we repair it to meet a new standard, will require some level of rework to meet a new standard. In that case, we need to get approval from the client and approval from the designers to change the project specifications to ensure they're happy with it and to ensure they accept it. Okay, let's wrap up with going through an example of a non-conformance report. So this is the type of form you'd fill out when raising an NCR. We'll go through the different structure of the form and talk about the specific example NCR we're talking about. So this NCR was part of an imaginary project called the Western Road Project, and it occurred on 27th of May, 2021. So at the top, we're just filling out the details of the NCR, the facts, what happened, the relevant documents, all these sorts of things. So the NCR name was underbore, missing tracer wire, and the engineer responsible. The work package was the combined services trench, so installation of underground conduits, and the subcontractor was underboring solution. The design package and reference, so the drawings that documented the work that was being undertaken and any relevant standards and specifications. There's a relevant quality lot, so what quality lot was the work being undertaken under, and then there's a description of the NCR. So let's look at the description. So the standard design details for the underbore, as detailed in the drawing, show 300mm electrical conduits and one 100mm communications conduit. Additionally, a 5mm steel tracer wire was meant to be installed as part of the bore. However, underboring solutions, the contractor drilled the bore, pulled through the electrical conduits. However, they failed to install the tracer wire. The bore was sealed, they finished the work, and only after did they realize the tracer wire was missing. We also got it as a product NCR. So you can have a product NCR or a process NCR. Product NCR is a failure to meet specifications relating to the product we're delivering. Process NCR is a failure to follow process. So this is related to the product. So the product is the finished underbore. The design showed a steel tracer wire and we failed to install this. So what are we proposing to do about it? So we're proposing to repair with concession. So we're not reworking to meet the original standard, we're reworking to meet a new standard. And so this is something that would have to get approved by our client and the design team. So we're asking to install a 5mm tracer wire within one of the spare 100mm conduits. So the original design showed that the steel tracer wire was installed separately to the conduits. However, we're asking to install it within the electrical conduits, and we're giving an explanation for why this is okay to do and how we're going to install labeling as well to show why it's been done like this. We've got a cause of the NCR, which was people. The subcontractor failed to review the drawings properly, and the contributing cause was the contractor did not properly understand the design. The process improvements is that we're going to update our inspection and test plans to ensure that future underbores we have a representative from our own team on site checking that this is done correctly. So we've got corrective action, what we're proposing to do about the defect. We've got gone through the cause, the contributing causes, and how we're going to improve processes in the future. We then take this NCR, we then submit it to the design team and the client to get their approval to ensure they're happy with doing it. Once they're happy with the proposed corrective actions, we then go out, physically do the works, close it off, and then we could successfully close the NCR. So through this process, you can see how we've encountered an issue with the installation, and we're going through a process to resolve this to ensure ultimately our client is happy with the product we're producing. This video is going to be all about how to more effectively manage construction project defects. The goal of this video is to teach you about the defect management process on construction projects so you can reduce the number of defects on your projects and significantly reduce the overall cost and the time it takes for you to deliver the project. According to research by the Construction Industry Institute, rework due to defects can cost between 4 to 6% of the total project budget. That's why in this video, we'll define defects, so we'll talk about what they are. We'll talk about why they matter, why they're critical to manage as part of achieving project success, talk about the different types of defects, and then talk about the process to manage, eliminate, and reduce construction project defects. So starting off with the definition. Put simply, a defect is any failure to meet specified requirements and standards for the project. A defect is as simple as that. It's any failure to meet the specified standards or requirements. So here's some examples of typical defects on construction projects. On a road project, we might have poor line marking. On electrical cables, we could have missing labels. In a concrete structure, we could have cracking. In the basement of a building, we could have water ingress, or on structural steel, we could have missing torque marks on the bolt. So these are just all small typical examples of the types of defects you come across on different construction projects. So all of these different items have the same characteristic. They're a failure to meet the specified standards of the project. So we go out, we deliver a construction project. As part of the quality management process, we're checking and verifying that what we're delivering meets the standards, that a defect is any failure to meet these specified standards. The ultimate goal of a quality management system is to eliminate defects, to have 0 defects, to hand over a finished project that complies with all of the specifications and standards, and there's no deviations from these requirements. So why do defects matter so much on construction projects? Well, to answer this question, you need to understand the 80-20 rule. If you've ever worked on a construction project, you'll find that managing the works, 80% of the works take 20% of the effort, and then the final 20% takes 80% of the effort. There is always a ton of small items at the end of the project that just consume so much time, attention, and resources to close out. And closing these out successfully is critical to getting paid on time, to finishing the project successfully, handing over to our client. And time again, you see construction projects fail, even though for the majority of the work they've been delivered successfully. However, through the closeout phase, there's all these legacy defects that quickly chew through the project's profit margin. Extending on this, we can categorize the reasons defects matter, and I'm going to explore each of these in more detail down to safety, value delivered, the customer and stakeholder satisfaction, contracts, cost, and time. So the first reason managing defects is critical to managing construction projects successfully comes down to safety. So the origination of any design requirements or specifications that go into the project documents often come from safety standards. For example, the strength of concrete on a bridge is critical to holding up all the cars, traffic that will go across it. If we don't meet those concrete strength requirements, we can't prove that the bridge is actually safe for all those different people to use. If we think of another example, insulation on electrical cables. If we don't have proper insulation on our cables, we could have an electrical fault that could start a fire. So ultimately, through the quality management process, we ensure that what we deliver complies with the specifications and standards, which directly ensures that what we're building is safe for people to operate and to use. A real-world example of this was the Surfside condominium collapse in Florida in the US. So failed waterproofing on the construction of a 12-story building led to corrosion in the steel reinforcement, with the structure ultimately collapsed and killed 98 people. So you can see deviations from the original standard, which was waterproofing of the concrete, led to a legacy issue that caused corrosion in the steel reinforcement and ultimately the integrity of the structure of the building, leading to a collapse that killed 98 people. So when we're talking about defects, we're not just talking about money. We're also talking about an ethical responsibility to ensure that what we're building is safe for use. The next reason defects matter is that the elimination of defects directly leads to additional customer value. Let's think about this. The project specifications and standards document what we're getting paid to build. Ultimately, each of these standards, each of these specifications directly relates to the value we're creating for the customer. So if we have defects in the product we're producing, we're ultimately producing something that isn't as valuable. So eliminating defects ultimately increases the amount of value delivered by the project. This then relates to my next point, which is the less defects we have, the more stakeholder satisfaction we have. So defects will ultimately impact the perception of the project by the client. So even if they're aesthetic and minor defects, we could build something that's perfectly fit for use, perfectly safe to use. However, if it's got a whole lot of cracking in the concrete, scratches on the walls, ultimately the way our client sees it, the way our client perceives it, is that we ultimately haven't delivered something valuable. They've got a poor quality product. So stakeholder satisfaction and defects are also directly related. Next, defects have important commercial implications. So when we're talking about the contractor building the project and they're ultimately responsible for delivering the project in line with the requirements and specifications, this requires them to produce product that is free of defects, because ultimately they're getting paid to deliver what the project specifications and requirements say they need to do. So ultimately there's significant contractual implications through contracts. Defects can impact payment, and they can also impact contract completion. So getting your security back, closing out the project at the end of the job. You see this a lot typically around payment on construction projects. So payment is always an issue on construction projects. Cash flow is the lifeblood of the construction industry, and payment is a powerful motivator. So regularly on projects, you see contractors make payment claims and principals reject the claims, not because they haven't necessarily done the work, but because they haven't done the work to the required standards and they can't prove that they have done so. So the principal is meant to pay the contractor based on the value of work they've completed, and often there's a dispute around valuing this work based on what both parties see as outstanding work or outstanding defects. So defects will always relate to payment on construction projects. This then directly leads on to the next issue, which is cost. So rework ultimately costs money. The cheapest way to deliver a project is to do it once. Do it right the first time, not to come back and do the same task again because you messed it up the first time. So the less defects we have, the less money we're going to spend. Defects can consist of both incomplete work, so work we didn't do the first time because we didn't have the materials, because we didn't have the access, for whatever reason, but also defects can consist of rework where we haven't done the work correctly, so we're coming back, and doing it again. Finally, defects matter because they impact the duration of the project. So quickest way to deliver a project, in the same way that the cheapest way to deliver a project, is to do everything correctly and completely the first time. If we have defects, if we have incomplete work, if we're coming back and doing things twice, it's going to suck up our resources and it's going to push out the duration of the schedule. So the quickest way to complete a project is to do it without defects, without rework. Okay, let's now talk about all the different categories of defects. So what are all of the different types of defects that exist on construction projects? So the first one, we can categorize defects based on their cause, whether they're caused by incorrect design, incorrect construction methodology, the wrong materials being used, missing equipment, these sorts of things. So defects can be broken down based on their cause. We can break down defects based on their significance. So are they aesthetic only? Is it paint markings on a wall? Or is it a significant defect that impacts the operation of the asset? Is it a missing electrical switchboard? So we can break them down based on the significance. We can also break them down based on who's responsible. Is it the responsibility of a subcontractor who's done something wrong? Is it because it's an incorrect design? Is it the responsibility of the designers to fix and get an answer to? And then finally, we can break them down by the type. Are they due to incomplete work, which we're waiting on materials to do, or is it because of an incorrect installation? So these are some of the different ways we can categorize and break down defects on a project. So how do we manage defects? We know defects are a problem. We know they cause significant harm to a project success. What can we do to manage them more effectively? Well, the quality management process ultimately exists to eliminate defects. So through the quality management process, we're directly addressing the presence of defects on a project. Our goal is to deliver a product that fulfills the project requirements. So the quality management process is there to identify and then close out and ultimately try to eliminate defects. So let's look at the quality management process and where defects are addressed and managed through this process. So it starts off with, as inputs to the quality management process, we get the project requirements, the design drawings, and any contract requirements. We then develop a quality lot structure. So this will be a list of all the work we have to do in the project, the same as a work breakdown structure. And against each of the individual construction requirements, we develop inspection and test plans. So an inspection and test plan is a document we use to check and verify that the work has been done correctly. Once we've developed our inspection and test plans, we'll go out and we'll complete the construction works. Against each of the activities, we do our inspection and testing. Where we fail inspection and testing, we record that as a defect, a non-conformance, a failure to meet the project specifications. These go into our punch list. We then work through our punch list, closing out all of the individual defects. And then when we've successfully completed the inspection and testing for some work, we've closed out the defects relevant, we can successfully close out the project work for that portion of the project scope. So that's the quality management system we use to ensure we're identifying defects, recording them, and closing them out, and then handing over a product that's free from defects. What's involved in completing and handing over a construction project so you finish successfully, make your client happy, and get paid on time? In this video, I'm going to explore the completions management process on construction projects. A study by KPMG found that 69% of construction projects fail to be completed on time, often caused by defects and rework. So project completions management is a critical part of construction project management. Understanding the completions management process is going to help you more successfully deliver projects and accelerate and grow your career in construction project management. So in this video, I want to talk about what is project completions, why it matters, the difference between quality management and completions management, the different types of project completions, the requirements to complete a construction project, and some tips on how to achieve project completions on time. So what is project completions? Well, throughout the course of a construction project, we take a set of drawings and specifications, we build the project according with these drawings and specifications, and then we come to the end of the project. What we need to do here is we need to take the finished product we've built, we need to hand it over to our client. So we need to get them to accept it, we need to finish the project, and we need to hand it over successfully to our client and finish our responsibilities. The client ultimately wants to make sure they're getting what they paid for, and they want to make sure there's a smooth transition to the next phase of the asset's lifecycle, which is the operation, maintenance, and usage phase of the asset. So the project completions management process is how we, as the builder, as the contractor, we facilitate this process for them. So project completions, if we want to give it a more professional, concrete definition. So project completions is the process through which deliverables are finished, inspected, and handed over to the client, ensuring the project meets the contract requirements and quality standards. So now that we understand what completions is, the next question I want to answer is, why does completions matter? So the first reason completions matter is cost. Poorly managed project completions leads to increased defects and rework for us, the contractor, to incur, an extended allocation of project resources to closing out the project. So these are things like management staff and supervisors that need to stay on the project for an extended period of time. And the final one is we'll incur liquidated damages and contractual penalties if we fail to hand the project over on time to our client. So our client will hit us with contractual penalties, which will also hurt the project's bottom line. The second reason project completions matter is because of contracts. So directly related to cost is contracts. So there's contractual requirements around project completions. Contracts will specify a certain date we need to finish the project, the practical completion date of the project, and the completions management process is there to ensure we finish the project on time. And we're contractually obliged to meet these dates. And as I just said before when I was talking about cost, if we fail to meet these dates, our client is justified in hitting us with liquidated damages and delay penalty costs. The second reasons completions matter is it matters to the client. So the on-time completion, as per the requirements, is one of the key metrics the client will look at in terms of justifying project success. The client wants to be able to use the asset by the date in the contract. So incomplete project work will also damage our reputation in the eyes of the client, and it'll damage the perceived value of the project. So now that we understand why project completions is critically important to the client in terms of securing new work, the costs of the project, and we're contractually obliged to ensure we achieve it, I now want to talk about the relationship between project completions and project quality management, because quite often I see people blur the two into one broader topic. However, quality management and completions management are related but different. So project quality management, as we know, is the verification and validation that what we built matches project requirements. Completions requires that the quality activities have been completed correctly. That's the core requirement of project completion. So project completions, to hand over the project successfully, we need to have completed all the quality activities. So we need to have checked that everything we've built matches with the project requirements, and we can provide evidence of this to our clients. So now we understand why completions matter and how it fits into project quality management. Let's talk about the different types of project completion. There are several different types and definitions of project completions that exist, and they vary depending on the degree of outstanding works and how the finished asset is accepted for use. So what are the different types of project completion? Well, the first one we've got is substantial completion. So substantial completion is where we get operational use of the asset, and the client can use whatever we've built except for some minor aesthetic defects. Second type is final completion. So final completion is where the project is fully complete with no punch list, and we've accepted and can take final payment from the client. Third type is conditional completion. So this is where completion occurs under certain conditions. For example, if it's a building, we might get a temporary certificate of occupancy contingent on us fixing some important outstanding works, or we might get partial completion, where this is certain parts of the asset get accepted and finished for use. However, we still need to finish other parts. So the piece of infrastructure we've developed is partially usable. So now that we understand what completions is, the different types of ways we can achieve project completion, let's talk about what's required for project completions. What do we need to do to successfully hand over the project to the client? And we'll talk about the sources of these requirements and the types of different requirements. What are the different completions requirements? Well, the first one is dependent on the contract model. There might be a contract model where we're designing, building something and maintaining it for 2 years. So then our completions requirements come in after 2 years of maintenance. It'll depend on the project specific. So the type and nature of the project. If we're building a power plant, our completions requirements will depend on being able to export electricity. If we're building a train station, it'll depend on opening that train station to the public. It will depend on specific client requirements. So this client might have specific requirements or systems that we need to use to achieve completions. For example, they might have an asset management system, and as part of our project completions, we need to upload all the different assets we've built to the system. Then finally, there'll be internal processes that govern completions requirements. For example, to close off a project, our company might require that the electrical license holder has done an inspection of the project and is happy with it. So these are all the different sources of completions requirements. Now let's look at what are the deliverables we need to complete to hand over a finished product. And to me, this is the crux of where the topic is. So I'm going to go through all of these different ones and look at what specific requirements exist around achieving. The first one is construction complete. So this is the physical completion of the construction works and making the asset ready to use. So if we're talking about a building, that'll come down to a certificate of occupancy. Talking about a solar farm, this will be exporting power to the grid. As part of finishing the construction works, we also need to complete our quality assurance. So these are the checks and verifications we make to make sure what we've built is correct. So that's how we prove that we have in fact finished the construction works. And this will come down to inspection and testing, documentation, recording everything, getting our client to sign off any hold of witness points, and compiling and submitting all of this documentation. We'll also need to complete handover walkthroughs. So these are joint inspections with the client to show them what we've built and get them to sign off and accept that they're happy with it. These walkthroughs, we give the client an opportunity to inspect the works and raise any defects that they've picked up so we can add them to our punch list. And as I was saying when I spoke about handover walkthroughs in project quality management, that design issues often arise. So it's important to have a member of the design team present on these walkthroughs. Commissioning is also an important part of project completions depending on the nature of the project. Now, for a bridge project, you're not going to have a commissioning process. However, for any mechanical or electrical projects, commissioning will be a large part of the project. So this will be function testing the installed systems to ensure they operate as project requirements. Commissioning will contribute to the punch list, so any defects picked up through the commissioning process will also need to be closed out, and there may be some witness testing, so some testing that the client needs to witness. We also need to close out all of our defects, so these will be identified during our quality management process, commissioning or handover walkthroughs. We need to close out all the different punch list activities so that our client accepts the finished work, and any outstanding minor cosmetic defects we might be able to close out after practical completion, but that would require acceptance from the client. To get completions, we'll also need to prepare and submit our as-built drawings to the client. So these are the set of drawings and specifications we maintained during construction, we documented any changes on, we send these back to the design team, they'll draft a new revision of the as-built drawing set, which we'll also need to submit to our client. In certain circumstances, depending on the completion's requirements, but I've seen it on quite a few projects, clients will want an asset register. So they'll want a list of everything we've installed, documented and recorded so we can submit to them, showing serial numbers, manufacturing, lead time, supply contacts, all these sorts of things. We may also need to hand over spare parts. So say we've procured a certain type of light fitting, we've ordered 100 of these light fittings. The contract may specify we need to hand over 5% of the installed spare parts. So we'd have to hand over 5 light fittings. And this just helps the client when they're going into maintenance, that if they have a fault, that they've got spares available to change them out. In addition to spare parts to replace, the client may also require us to provide any special tools or maintenance equipment to run the asset. And we may also need to prepare and submit an operations and maintenance manual. So this would be detailed maintenance instructions for how to run the asset, how to manage whatever we've built. So this will document things like the frequency, the need to perform inspections, the different types of inspections and tests, corrective and preventative maintenance, how to do fault finding, or certain supplier contacts. So this is basically a big document that shows clients how to run the asset, how to maintain it, and how to use it, documents all the supplier contacts, and basically just makes the way for them to go from the construction phase to the operations maintenance phase much easier and smoother. In addition to the operations and maintenance manual, they might also want us to conduct a series of training sessions. So these will be training sessions to familiarize the operations and maintenance team, the usage team with the plant. So we'll have to show them how to use it, how to operate it, the different types of faults. We might have to give them a list of logins and passwords if we've created any software that they'll have to use. Basically just all these sorts of types of things. So it's really, again, about making the process for the client from moving to the construction phase to operations and maintenance phase as easy, simple, straightforward as possible. Depending on the contract requirements, we might have maintenance or a defect liability period we need to work through. So this is where us as the contractor for a certain period of time are responsible for providing continued maintenance and defects rectifications. This might be a 2-year period where we need to come to site and come back to rectify any defects or faults arising from the construction activities. And while this won't impact our initial project completion, at the expiration of the maintenance period, we'll need to perform another completions process to show that we've completed this maintenance correctly. So again, this will depend heavily on the specific requirements of the contract. Depending on the specific project requirements, there could be a whole range of other completions requirements like sustainability requirements, green star requirements. Might be some building or plant tuning where we're helping with configuring the commissioning and the operations to maximize the plant output. We might have to give them certain permits, licenses, certificates of occupancy, or hand over a pack of the different warranty information for all the different suppliers. Any of these things will depend highly on the project specifics, but as you can see, all this documentation is there to make the transition from the construction phase to the operations and maintenance phase as easy as possible. To manage completions effectively, we need to submit everything to complete the job. So that's why the completions management process is all about identifying everything we need to submit and starting working on it as early as possible to hand it over on time. So my tips to make sure you hand over your construction project on time is to treat completions as an individual function, an individual set of activities, and document these in the project schedule. Document all of these completions requirements where they're going to be reported on and where people are going to see them and they're going to see if they're slipping. Document these requirements early and make every effort to submit them progressively. The only way you're going to hand over your project on time is to start thinking about completions in the planning phase, document all the requirements, and work through the process methodically, the same as any other function, the same as any other task on the project. So we've pretty comprehensively covered quality and completion systems and how they work. Now let's talk about where things tend to go wrong. How do mistakes within the system cause issues with time, money, and credibility? By far, the biggest mistake I see is people underestimating the importance of document control. A manager once said to me, document controller is the most important person on the project. It's always stuck with me, and increasingly as I progress in my career, I see more and more how true this comment was. The amount of avoidable mistakes and chaos I've seen from people building off the wrong sets of drawings, avoidable reworks, cost blowouts, hours lost chasing missing test reports, construction projects delayed from missing drawings, incorrectly sent RFIs. All these issues just cause absolute nightmares and chaos on projects. Construction projects generate hundreds, if not thousands of documents. And if you need a system to manage and check they're correct and maintain version control, because if you don't, it will cause you absolute nightmares. The second mistake I see all the time is people overcomplicating a quality assurance system. Every project you go on has someone who says, we do things differently here, we're using this special fancy system, but all they're really doing is reinventing terminology and overcomplicating something that's really not that hard. Quality assurance system is really about defining what testing we're going to do, doing the testing and submitting it at the end. Doesn't need to be any more complicated than that. You don't really need to come up with your whole range of different terminology and words. All we're really doing is checking things against requirements in a systematic way. It's not rocket science, so always try to keep it simple. The third mistake I see a lot is that people just let quality assurance get out of hand. Quality assurance systems don't fail overnight with some dramatic failure. What happens is they tend to slip a little bit each day when people are busy, and before you know it, you miss one inspection, you skip a few photos, you forget to file a checklist, and then suddenly you're writing NCRs because you haven't followed the process. You're searching, spending hours searching for missing test reports. Your client's not paying you or withholding payment because you can't submit a check. Your management's getting cross at you, and you're burning days in admin and stress. The lesson is just to stay on top of it. Make it a regular practice. Quality assurance is all about discipline, not scrambling. The next big mistake I see is people ignoring requirements. Now, this is very much to do with commissioning, but people tend to think about handing over the project till the end of the project, but often getting all of these requirements together takes a lot of time. For example, spare parts. You have to order the spare parts, they have lead time, you need to organize vendor training. All these different requirements tend to take a lot of time to get together, and people don't think about them to the very end of the project, and suddenly they're waiting months to provide the final documentation. And if you don't track these from the very start of the project, you'll never hand over on time. So the fix is to define the deliverables, the requirements your completions system has to achieve, assign responsibilities early, and then simply follow these up regularly. Set it up at the start, monitor it and control it, and you'll finish on time. The next mistake is people gold plating the QA system. People get excited when they write ITPs. They want to make everything perfect. They say, oh, we're going to take a photo of the trench every 20 meters showing the depth at the bottom, the width, blah, 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 blah. All of a sudden, sounds great in practice. Then all of a sudden you're in the field and you've got to take 2,000 photos of trenches. You've got to file them, you store them. And because you've written it in the RTP, the client signed off on it, you've said you're going to do it, it's effectively now a requirement of the project, it just ends up wasting no time and you get nothing for it. It doesn't actually improve the quality objectives of the project. It doesn't do anything to improve the outcome. So the main takeaway is only track what matters, keep things as simple as possible, focus on the core objectives of the quality management system, producing evidence that you comply, preventing mistakes. Keep it as simple as possible. Don't get overexcited, and it will be much easier for you to stay on top of it. The next mistake I see when it comes to quality, and it relates to what I was saying about the snowball effect and letting things getting out of hand, is people skipping the process. Cutting corners feels efficient in the moment, but it will always come back to bite you later. You install something before sign off, you tweak the design but skip the RFI, you borrow a certification from another job. Something will come up, something will come back to bite you, and it will be 10 to 100 more times work to fix than the work you avoided by cutting the corners. In my experience, shortcuts always lead to future problems. The next big mistake I see that happens during the tender phase is not defining the quality assurance and completions requirements in contract, which basically will lead to scope growth. So having to do testing or completions, things that we didn't allow for in the budget or estimate, or getting into disputes about client of what we have to do to hand over the project. Quality assurance, completions, buying spare parts, doing additional testing all costs money and takes time. So it needs to be defined during the tender stage like any other project task. Most quality assurance issues aren't technical, they're management mistakes. Keep it simple, start early, stay on top of it, and don't leave all the paperwork to the end. Quality assurance is about discipline, not being smart, creative, or doing things over the top. It's about staying on top of it, dotting your I's and crossing your T's.